Lesson 1-6, Multiply Integers. In this lesson, we're going to learn how to expand our knowledge about adding integers into the operation of multiplication. Let's take a quick look at the Explore It problem. A popular beach erodes 4 inches per year on average. Well, first of all, we need to know what the word erode means, and you might remember this from science class. Okay, erosion is a type of wasting away. So in other words, the beach is disappearing 4 inches per year on average. So question A says, how many years will it take the coastline to erode 1 foot? Well, we know that there are 12 inches in a foot. And if it's eroding 4 inches per year, we're looking for the amount of time it will take for it to erode 12 inches. In this problem, erosion would represent a negative integer. In other words, 4 inches of coastline are disappearing each year. So what can I multiply by a -4 in order to get 1 foot of erosion, which again in this case would be a -12? So how many groups of -4 do we need to get to -12? Well, remember, we can look at this multiplication problem from the standpoint of repeated addition. So after 1 year, the coastline would erode 4 feet. After 2 years, it would erode another 4 feet, which is a total of -8 feet. And then if I add 1 more year of erosion, I will get a -12. Therefore, -4 times 3 equals a -12. Now take a look at part B. The number line below shows the expected change in the coastline as years pass. How could you use the number line to show the erosion after 10 years? Well, if 0 represents the coastline this year, then we could repeatedly add groups of -4 until we got 10 years down the road. There's 7, and I would have to expand this. 8, 9, 10. So the question is, what number is this point right here on the number line? So if we're counting by -4, we go back -4, -8, then we have -12, -16, -20, -24, -28, I'm running out of space, sorry, -32, -36, and -40. Again, we can also look at this from a multiplication standpoint. If we know that the beach is eroding 4 inches per year for 10 years, then we would know that -4 times 10 makes that -40 inches after 10 years. And the way the number line helps us get that information is by repeatedly counting by that -4. Now let's take a look at the essential question and example 1. How do the signs of factors affect their product? Remember, factors are the numbers within that multiplication problem. Okay, so these are your factors. And your product is the answer. Example 1. In this example, we're going to learn about multiplying a negative integer by a positive integer. While playing a board game, unlucky Lawrence had to move back 2 spaces for 4 turns in a row. What integer represents his change in position? We can use both a game board or, in this case, even easier, a number line in order to represent the change in his position. So 0 is going to represent Lawrence's starting position. He moves back 2 spaces, so you can see here that we've got groups of -2, -2, -2, and -2, okay, because moving backwards would be a negative number. And he has to do this 4 times in a row. So 4 groups of -2, or repeatedly adding -2 together 4 times, is going to give us a product of -8. So -8 represents the change in position on the board, or unlucky Lawrence had to move back a total of 8 spaces. Now the second strategy that they show you over here on the right side of the page is not a very common strategy that students tend to use, but I'm going to go through it anyway just in case this makes sense to you and you find that it's helpful. Use multiplication and properties of operations to show why 4 times -2 equals -8. So the first thing that I want to do is I want to take a look at this very first line here that says 4 times, and then in parentheses, -2 plus +2 equals 0. So they've completely changed the question on us. And what they're trying to get us to understand is that 4 times 0 equals 0. Would you agree with that? Any number times 0 is 0. So they've expanded that 0 in the multiplication to use additive inverses. In other words, -2 and +2 make 0. Those are your additive inverses. Okay, we can also use that 0 property of multiplication to rewrite that in this form. And then we have what we use called the distributive property, where we take that 4 on the outside and we distribute it and multiply it times each piece inside those parentheses. So the 4 on the outside gets multiplied by the -2, which you see here. And the 4 on the outside gets multiplied times the +2, which you see here. Now, together, 4 times a -2 plus 4 times a +2 should still equal 0. Now let's take a look at the next line. 4 times -2 is actually the problem that we're trying to solve. We already know that 4 times 2 is equal to 8. So now the question is, what number can I add to +8 to make 0? In this case, we know that it has to be its opposite, or its additive inverse. We know that -8 and +8 make 0, so what goes in that red box here, in this red box, has to be a -8. In other words, 4 times -2 is that -8 in order to make that entire structure correct. Now, in general, this is the important piece. Okay. Anytime you have a positive and a negative number multiplied together, the answer is always negative. So positive times negative equals negative. Now see if you can complete the try it. If the boxes aren't making sense, then you can work over on the white space and try that question on your own. Then come back and check your answer when you've finished. Okay, go ahead and check your answer. Did you notice that taking away those 6 points is going to produce a -6 integer? So if we take away 6 points on 10 different cones, then that means we will have taken away 60 points altogether. So the change in total points is a -60. Now look at the convince me. Is it ever the case that the product of a positive integer and a negative integer could be positive? And the answer is no. Remember that multiplication is repeated addition. So repeatedly adding a negative number will always produce a negative answer.